Okay, welcome everybody to cloud computing. Okay, so let's start off with what is cloud computing. So it's the on-demand delivery of compute power, database storage, applications, and other IT resources through a cloud services platform via the internet with pay-as-you-go pricing. AWS started this cloud computing in 2006, where they sold IT infrastructure services to businesses as web services. It provides a simple way to access servers, storage, databases, and a broad set of application services over the internet. A cloud services platform owns and maintains the network connected hardware required for these services, while you provision and ultimately use what you need. It helps build and run applications, and it can also be used for deployment and management of these applications. It's available to hundreds of thousands of customers across 190 countries, and it offers powerful resources at a low operational cost. It has classically provisioning services like the Goldilocks problem, and with AWS, you can elastically scale up and scale down to your need. Okay, let's now talk about cloud benefits. So, the ability to deliver innovative new features to the market quicker, a focus on adding differentiated value, making new ideas feasible that were once out of reach, experimentation becoming fast and low risk, being able to adjust to fit any workload, and ultimately helping businesses serve their customers globally without the need for expensive, time consuming expansion. You can deploy web services using tools and languages such as Chef, Visual Studio, PHP, Java, Python, etc. You can connect to personal infrastructure by a private dedicated connectivity. And these are all of the benefits that the cloud provides and that you can use to your liking for your company and your product. Okay. Okay. So continuing off of this, we have a few more possible benefits that you can use, such as trading capital expenses for variable expensive, benefiting from massive economies of scale, being able to no longer guess about capacity and, of course, scale up and down when needed, the ability to increase your speed and agility, and being able to stop spending money running and maintaining data centers, and, of course, an important one, going global within minutes. So let's go into more detail on each of these. So for trading capital expenses for variable expenses, you only pay for what you consume, and you only pay when you are consuming it. For benefiting from massive economies of scale, it offers a lower variable cost, and you can achieve higher economies of scale, and it will lead to lower prices. Also, stop guessing about capacity. So, like I said, you can access as much or as little as needed, and you will be able to scale up or down when necessary within a few minutes' notice. Increasing speed and agility. So this is where you reduce the time it takes to make certain resources available, and and this can cause a large increase in agility due to cost and time to experiment being extraordinarily lower than before. And you can also stop spending money and maintaining running and maintaining data centers. So this will help you be able to focus on your own customers. And then finally, you can go global in minutes. So you can deploy your application in multiple regions around the world extremely quickly in just a few simple steps. And this means that you can provide lower latency, so delay before the transfer of data, and a better experience for your customers at the smallest possible cost. And so all of these in this slide and the previous slide are all of the cloud benefits that you can get, and that are useful because you can customize them to your company's need. Okay, now we're going to be talking about TCO, or the total cost of ownership, and what that is. So this TCO reduces the need to invest in large capital decisions, and it's useful because it provides a pay-as-you-go model that allows you to invest in the capacity you need and use. So as you can see here from the few previous slides, a big trend in cloud computing and using the cloud is the pay-as-you-go model. These TCO calculators are going to allow you to estimate the cost and savings that you'll be dealing with, and they're also used to modify assumptions that best meet your specific business needs. They provide directional guidance on possible savings, and the actual tool is built on an underlying calculation model. And so it generates a fair assessment of the value that a customer may achieve. But what's really important about this is to note that the results that the calculator pumps out is only used as an approximation, and you should always be ready for a little more. And as said before in all of our previous presentations, all the videos for extra content and information are going to be posted in the description of the live stream once we've actually finished the live stream. And you can watch them on your own time to learn more about certain topics which are being covered throughout the presentations. Okay, starting on day 2, we're going to be talking about the three different types of cloud computing. So there are several different models of cloud computing, and this allows different amounts of control over the web services. The three main types are infrastructure as a service, which is IaaS, platform as a service, which is PaaS, and software as a service, which is SaaS. So you can also see there's an extra one in the picture, which is on-site, and that means that you'll be managing it fully. Infrastructure as a service, or IaaS, contains the basic building blocks for cloud IT and is known for typically providing access to networking features, computers, so this could be, of course, virtual or dedicated hardware, and data storage space. It's the highest level of flexibility and management, and it is most similar to existing IT resources, and it has instant computing infrastructure. Alright, now moving on to platform as a service, or PaaS. So this removes the need for organizations to manage the underlying infrastructure. So this is usually for hardware and operating systems. It allows focus on the deployment and management of these certain applications, and it helps business owners be more efficient because it disregards human concern over resource procurement, capacity planning, software maintenance, patching, etc. And as you can see, this is a combination of hardware and software components. Okay, finally, software as a service, or SaaS. So this provides customers with a completed product that is run and managed by the service provider. SaaS is usually referred to as end user applications, and it has no user concern about service maintenance or how the infrastructure is actually managed. So you will only need to know how you're going to use the software. And an example of this is using web-based email to send and receive emails without having to manage the feature additions that they may bring. And you can see in the picture that it has some of the images of things that it controls. And again, all the videos that are in this presentation are going to be posted in the description, so you can watch them whenever you feel like doing so. Okay, moving on to day 3, how to deploy the cloud infrastructure easily and with the least amount of problems. So there are 4 main key areas to actually do this and to make deploying cloud infrastructure easy. Number 1 is the highly trusted global infrastructure. A Number 2 is providing broad compatibility with all popular workloads, having fast and secure private networking, and using tools to control access to all cloud resources. So for highly trusted global infrastructure, it is designed for high security and availability needs of the large enterprises. It offers capabilities that restrict unauthorized access or usage without having to sacrifice flexibility, and it is a used as a backup for all features. For providing broad compatibility with all popular workloads, it can spin up virtual servers, hard drives, databases, networks, and more. And you can easily set up these virtual servers using either Linux or Windows. For fast and secure private networking, this provisions a private section of the AWS cloud that you define and you retain control of. It is done with simple IP networking, and as a result of this, the cloud environment becomes an extension of your on-premises environment. It uses a standard pipe that encrypts data when it moves from your environment to the cloud, and more data creates dedicated network connection from your existing data centers to AWS. This gives you predictable network and a performance increase because it bypasses the public internet, so less clutter. And tools to control access to all cloud resources. So here it creates and manages users and integrates it with your existing identity systems, and it is able to give greater flexibility to rapidly create new apps, lower costs for existing apps, and benefit from the global infrastructure and security of AWS. Okay, now let's talk about the actual cloud. So, applications that are based in the cloud are, of course, fully deployed within the cloud, and they are also created inside the cloud. They could be created inside the cloud, or they are migrated from an existing infrastructure to take advantage of the benefits. Cloud-based applications are able to be built on low-level infrastructure, and they can also use higher services that provide detachment from management, architecting, and scaling goals. Let's talk about hybrid cloud storage. So this is a way to connect the infrastructure and its applications, and it connects cloud-based resources and existing resources. A common method of hybrid deployment is to extend and grow an organization's infrastructure into the cloud while connecting the cloud resources to the internal system. And this runs applications in both the cloud and on-premise. And therefore, you can access Amazon Web Services whenever necessary. But as you can see in the picture, hybrid cloud storage also has its challenges. On premises, you can say that you want to run your existing applications without change, but in cloud, you will be able to leverage the infinite scale of the cloud. For hybrid on premises, you can say you need local access to data in the cloud, and in the cloud, you can have this while accessing the power of cloud compute and analytics. On premises, you might say that the compliance requires that you integrate with enterprise security and management tools. But in the cloud, you would want to manage and monitor from a single pane of glass. On premises, you can say that you need reliable, easy connectivity to the cloud, and in the cloud, you'll have it even when your data is in many locations. Okay, going into more detail on on-premise. This is referred to as the private cloud, and it uses virtualization and resource management tools. On-premises deployment leads to the inability to receive cloud computing premise benefits, and it's used to provide dedicated resources, typically the same as the previous IT infrastructure. And it uses application management and virtualization technologies to attempt to increase resource usage. And this is a video on cloud versus hybrid versus on-premise, which of course you can watch whenever you feel like doing so. Okay, let's start off day 4 now. So AWS security. AWS infrastructure installs safeguards in order to protect the user's privacy. This data is kept in highly secure data centers, and it manages dozens of compliance programs. Segments of this compliance have already been completed. It has the highest security without the user managing their own facility. It saves money at the same time. You can scale the security with your cloud usage, and you can maintain the security regardless of the cloud size. This is a video on AWS cloud security. Okay, analytics services. So this set of services is used to handle every step of the analytics process. The services here are powerful, flexible, and yet simple to use, which thus enables organizations to put their unorganized data to work efficiently. Here are some examples. So Elasticsearch, Amazon Kinesis, Amazon Redshift, and Amazon Athena. So Elasticsearch is an open source search and analytics engine which is used to log analytics, real-time application monitoring, and user click analytics. Amazon Kinesis enables you to absorb, buffer, and process streaming data to find insights promptly. Amazon Redshift can ask questions and combine exabytes, so a 10 to the 18th byte, of organized and disorganized data across your data warehouse, operational database, and data lake, which is a centralized repository that allows you to store all of your structured and unstructured data at any scale, using a language which is called SQL, or Standard Query Language. And lastly, Amazon Athena is an interactive question service that makes it simple to analyze data in Amazon Edge 3 using SQL. Now talking about compute services. So AWS offers many services that can deploy, run, and scale applications as virtual servers, containers, or code. Examples of this include Amazon EC2, which obtains servers quickly and inexpensively, Amazon Lightsail, which creates a virtual private server or a VPS on AWS, and an Amazon Elastic Container Service or ECS, which runs in Docker containers, which contain software that are in standardized units known as containers. And these containers package everything a software needs to run, including libraries, system tools, code, and runtime. Okay. AWS database services. So these are necessary databases for applications such as managed relational, non-relational, data warehouse, in-memory data store, and graph databases. Amazon DynamoDB offers fast and flexible database service for any workload. You only pay only for what you utilize, and it's a key value database that delivers nearly instantaneous single-digit performance at any scale. It's built to handle internet applications. It's a fully managed service and handles more than 1 trillion requests per day. Finally, we have Amazon Relational Database Services on the slide, or RDS. So this is a relational database service with 6 well-known database engines, and it can be set up, operated, and scaled in just a few steps. And we have a video here on the slide which helps you to understand RDS if you'd like to watch that later. The video is only 2 minutes long, and it will be posted in the description of the live stream. Alright, finally, day 5. AWS Developer Tools. So these contain code and automatically create, evaluate, and deploy applications. It's a set of services that quickly and carefully deliver software, and these services store and hold control of your application's source code. It's used for constant integration, continuous delivery, infrastructure as code, and monitoring. AWS Code Pipeline can create an end-to-end software release workflow using services, and it is a continuous delivery service that automates the release of pipelines in order to have fast and reliable application, as well as infrastructure updates. It effectively and efficiently delivers features and updates. Now for the Cloud Development Kit. This Cloud Development Kit, or the AWS CDK, is an open software development structure to define your cloud application resources using known programming languages. It supplies cloud applications, and it can be a challenging process that requires you to perform manual actions, write custom scripts, maintain templates, or learn domain-specific languages. CDK utilizes familiarity and expressive power of programming languages in order to model your specific applications. And finally, there's AWS Code Deploy, which is the tool that installs applications and updates servers. It lowers the workload on developers and quickens the releases of new products and features. The Code Deploy makes it simple for users to rapidly release new features, help dodge downtime during application deployment, and deal with the complexity of updating applications. The positives of this include automated deployments, minimized downtime, centralized control, and being easy to adopt. Okay. The management tools allow you to provision, monitor, and set forth your cloud environment. You can maintain the stable control without restricting your development speed. For AWS CloudWatch, it's a service which was built for developers, system operators, site reliability engineers, and IT managers. The CloudWatch provides information and insights in order to monitor your applications, understand and respond to system-wide performance changes, optimize resource utilization, and get an allied view of operational health. It gathers monitoring and operational data in the form of logs, metrics, and events, which provide you with a linked view of AWS resources, applications, and services that run on AWS and on-premises servers. Now for CloudFormation. It provides a common language to supply important assets in the cloud. Provisions can be automated to be sent over and over and over again, and they model infrastructure using a simple text file. And for AWS Systems Manager, it allows full control of the structure of AWS. It automates tasks needed for smooth operations, helps guarantee security and compliance, and detects problems quickly. Now, for networking and content delivery services, it allows you to isolate your cloud infrastructure, scale request handling capacity, and connect the physical network to the private virtual network. The networking products would work together in order to meet requirements. For elastic load balancing, it coordinates with Amazon Virtual Private Cloud or VPC to give networking and security features. And it distributes application traffic among different services. It handles traffic in one or more availability zones or data centers and improves the scalability or adjustability of your applications. Now for storage services. It's a reliable, secure, and adjustable location for your data in AWS because they offer a wide variety of cloud storage services to support both application and archival of compliance requirements. Archival requirements are the dates when things can be archived, so stored away, and they're pretty hard to get back. And one can choose from different options to build the base of your cloud storage management solution. In AWS, different types of these storage services include object storage, file storage, block storage, backup, data transfer, and edge computing and storage. And this is a video on the introduction to AWS Web Services, which can be found in the description of the live stream. Okay, and that is going to be it for cloud computing today. Thank you for joining us, and we'll see you next week where we go over innovation. Thank you, everyone.